In this video, we are going to talk about triangles and quadrilaterals and their properties. More specifically, midsegments and medians. Midsegments and medians are different ways to split apart polygons. We're going to make some conjectures, which means basically make some theories about these breakups of the polygons, and then we're going to test them. We can try to give some examples to support our conjecture, or we can, if we see that it's not true, the conjecture is not true, we can provide a counter example. So first, let's define what a midsegment is. A midsegment is made by taking the points of two adjacent sides. That means adjacent means they're beside each other. And draw a line segment to connect the midpoints. Okay, so we need to start with the shape. Let's start with the quadrilateral. Okay, so we have basically a quadrilateral here. The lines aren't perfect, but it gives you the idea. And if you want it to be perfect, you can use a straight edge or a ruler. Or if you're drawing here in paint, you can also use a line tool to make a straight line. So the midsegment is made by taking the midpoints of two adjacent sides. So we want to take the midpoints. So we can use a ruler and measure at a length. So say we're trying to measure between this point and this point, and we use a ruler. We could find the midpoint to be right here. And we want to take the midpoints of two adjacent sides. So this side here, we've already done. Now we need another side that's adjacent, another side that's beside. So let's do this one here. Okay, we use a ruler and we measure, and it'll be right here. So you can see that what I'm doing right now, I haven't used a ruler and I haven't used straight edges, but you can absolutely do that on paper, so please do. And then we're going to connect it. So here's a way to show that we did a midpoint, and here again that this was a midpoint, and we connected it together. We could continue to do this for all of the sides of this quadrilateral. We can continue to find the midpoint and the other midpoint. And draw all the midsegments inside the quadrilateral. Notice how it also formed a quadrilateral? Okay, let's talk about some of these words. Counter example. So a counter example is an example that disproves a theory or conjecture. So basically, you're giving an example that shows that someone's wrong or that an idea is wrong. Okay? So conjecture. Someone can make up this theory, this idea. Conjecture. The midsegments of a rectangle form a square. Well, down below we have this rectangle, and you can easily see that when you make these midsegments, they are not forming a square. We know that because there's a 53-degree angle here, and a square would have to have all 90-degree angles. So this picture, this drawing, is a counterexample. It disproved. So an example could help to support a conjecture. So if I thought that this was true, midsegments of a rectangle form a square, I could start making some exact drawings on grid paper and try to come up with some examples of rectangles where the midsegments form squares. And if I was able to make drawings where the midsegments were squares, then that would be supporting the conjecture. It wouldn't be a proof. A proof would have to show that it's always true for every rectangle in the whole wide world. Well, I can't draw every single rectangle in the whole wide world. That would take me my whole life and it would keep going because rectangles could be any possible size. So just making a specific example is not enough to prove, it's just enough to support, to show a bit of evidence that the conjecture is probably true. On the other hand, you only have to give one example that doesn't work to disprove. Only one counterexample is needed. Okay, so I'm going to give you an example here that's not a math example at all, just so you understand the terminology better, hopefully. So, if I make a conjecture, all female blondes like pink. I could make some supporting examples. I am a blonde, and I like pink. So that's support. I ask someone else. Audrey's a blonde, and she likes pink. That's a supporting example. So they match the conjecture, they support it. Some blondes like pink. It hasn't shown that all female blondes like pink, but some do. To disprove it, we just need one example. So I asked my friend Brianna. Brianna is a female blonde, and she does not like pink. So this example, Brianna doesn't like pink, this disproves the conjecture. So Brianna is a counterexample. Brianna disproved it. All female blondes like pink. Well, in the set of all female blondes, who like pink, Brianna's over here. She likes purple. She does not like pink. So someone doesn't like pink, not all female blondes like pink. That's the idea of a counterexample. Sometimes it's actually easier to disprove something than to prove it. Now, if we go back to this example we saw up here, the conjecture was the midsegments of the rectangle form a square. And we could see right away it didn't form a square. But if we look at this shape, we can see it does form a parallelogram. And I think it actually forms a rhombus. Look at the lengths here. They all seem to be over 3 and 1.5. Over 3, 1.5. I think it actually forms a rhombus. So we could make a conjecture. We could say the midsegments of a rectangle always form a parallelogram, or the midsegments of a rectangle always form a rhombus. It is very tough to prove it, but you're often asked to support your conjecture with examples or provide a counterexample. So if we want to show that it's true, we really think it's true. So let's try our best to draw some rectangles. And we're going to try to show that no matter what the shape of the rectangle, the midsegments I still want that this color. The midsegments form, oh, well, I was just saying parallelogram, but in the question I already typed rhombus. So let's try to show it forms a rhombus. Okay, so this length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's great. I don't even need a ruler. 1, 2, 3, 4, 5 is the mid segment. And here 1.5, 1.5, 5. Let's draw some lines. So midsegment, 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 and midsegment. Okay, how do we even know whether this is a rhombus or not? Well, a rhombus has very specific characteristics. A rhombus all four sides are equal. And we also know that opposite sides are parallel. There's a shortcut for saying parallel. We go like that. Opposite sides are parallel. So let's figure out these lengths. If you have a ruler, you can bring your ruler up and measure it. If you're in GeoGebra, you can measure it. But unfortunately, right here in Paint, I don't have those tools. I could get a ruler. That would absolutely work. But I can use the grid to help me too. So notice that this is down 1.5 and over 1, 2, 3, 4, 5. So it has a certain length to it because of that. It would be easier just to measure with a ruler. You can see that this length is equal to this length. Make your drawing, make your own rectangle, get out a ruler, and you can see that definitely all of these sides are equal length. Now we need to show that they're parallel. Well, it's really easy to show that they're parallel because we're on a grid. All we need to do to show that two lines are parallel is to show that the slopes are the, I hope you said same. So let's do the slope. It's kind of helpful. We already have the slope right here. So up 1.5 over 5. So the slope of this line, actually we should say it's down, I'm sorry about that, down 1 over 5. And the slope of this one is up 1.5 and over 5. I missed the half. Okay, let's do the slope of this piece here. This one is down 1.5 and over 5. And the slope here is up 1.5 and over 5. Up 1.5 and over 5. Okay, usually for final answers we don't put decimals and fractions together. Usually we would write this, multiply the top by 2 to make it a whole number, make it 3, and the bottom a whole number. So usually we would give an answer like 3 over 10. But right now we're just trying to show that the slope's equal, so I'm not too worried about proper mathematical form. I just want to show the opposite slopes are equal. So this slope and this slope, they're opposite sides from each other and they are parallel. And this side and this side, they are opposite each other and they are parallel. Great. Notice that you can also use the points if you have it on a grid system, and if you defined the axes, you could label each of the points. So say you had the axes here and here, it can be helpful to say this point is 1, 2, 3, 4, 5.5. Sorry, x0, y 5.5. So it can be helpful to list out all the points. And then you could use the points to find the slope if you needed to. But luckily our grid was nice enough here that we could figure it out just using the grid. Okay, so this example of this rectangle that was 3 by 10 helped to support that the mid-segments of a rectangle form a rhombus. We didn't prove it, but we did help to support it. Let's do another example.